In the high-stakes world of digital security, there's a constant arms race. Today, we're diving into the story of a clever new strategy that totally outsmarted the giants. It's about a tool called QSYM and how it found critical bugs that even massive, well-funded projects completely missed. Let's get right into it.
So to really get what makes QSYM so special, we have to start with a fundamental question. In this race to find software flaws before the bad guys do, what if the winning strategy isn't about being perfectly thorough, but about being pragmatically clever?
And that question, perfect versus clever, well, it gets right to the heart of what we call the bug hunter's dilemma. The reality is every single piece of software you use, from your web browser to your phone's operating system, is riddled with hidden flaws or bugs. Security researchers are in this constant, non-stop race against hackers to find and fix the really dangerous ones before they can be used against us. It is a massive, unending job that literally keeps our digital world from collapsing.
Now, to help in this race, researchers have developed automated tools. You can think of them as bug-hunting bots. And for a long time, there have been two main schools of thought on how these bots should work. You can think of it as a tale of two very different bots.
So on one side, you've got the sprinter, a technique we call fuzzing. It's all about raw speed. And on the other, you have the maze solver, or concolic execution, which is all about intelligence. The sprinter is fantastic at finding the simple, low-hanging fruit, but it gets stuck the second things get complicated. The maze solver, well, it can find these incredibly deep, complex bugs, but its methodical approach is painfully slow. Let's break down what that really means.
First up, fuzzing. This is our sprinter. Imagine you're just throwing millions and millions of slightly changed files at a program over and over again just to see if one of them makes it crash. It's a pure brute force approach, but man, it is incredibly fast, and it's actually really effective at finding certain types of vulnerabilities. And then there's concolic execution, our maze solver. This bot doesn't guess, not at all. It carefully analyzes the program's code, treating it like a giant, complex maze. It solves these intense logical puzzles to figure out the exact input needed to navigate a specific path and unlock a hidden door. You know, like finding the one password that matches a specific value. It's brilliant for sure, but as you can probably guess, it takes a ton of time.
So the obvious solution seemed to be, hey, just combine them, right? Create a dream team. But that dream, well, it didn't quite work out as planned.
The idea was called hybrid fuzzing. You let the speedy fuzzer handle all the easy parts, and then when it gets stuck at some complex logical gate, you call in the smart maze solver to figure it out. It sounded absolutely perfect on paper. You get the speed of one with the brains of the other. What could go wrong?
Well, when researchers actually tried to apply this to complex, messy, real-world software, it wasn't effective. The dream team was failing. So what was the problem?
The researchers behind QSYM figured it out, and as this quote from their paper shows, the crucial point is this. The maze solver, the concolic executor, was just too slow. It was so slow that it created a massive bottleneck, grinding the whole hybrid process to a screeching halt. The sprinter would be just sitting around for ages, waiting for the maze solver to finish its calculations.
And this is where our hero, QSYM, enters the story. Because instead of trying to make the perfect maze solver, its creators decided to make a clever one. QCM's entire philosophy can be boiled down to this: pragmatism over perfection. It realized that being good enough and incredibly fast was way more valuable than being perfectly accurate but painfully slow. In other words, it was designed to cheat. And QSYM's strategy relies on three main cheats. First, it uses surgical precision in its analysis. Second, it makes these optimistic guesses when a problem is just too hard. And third, it learns how to skip the boring, time-consuming parts of the code. Let's look at each one, because this is where the magic really happens.
Okay, now this is where things get really clever. The first cheat is surgical precision. See, previous tools would get totally bogged down analyzing every single instruction in a block of code. But the creators of QSYM made a startling discovery. On average, a whopping 70% of those instructions were completely irrelevant to solving the path. So QSYM was designed to surgically identify and focus only on that 30% of instructions that actually matter and ignore the rest. The time savings were just enormous. The second cheat is what they call optimistic guessing. When it's faced with a puzzle that's just way too hard, QSYM doesn't give up. It takes a gamble. It identifies the most important piece of the puzzle, solves for that, and then makes a really educated guess on the rest. Then it just tosses that guess back to the speedy fuzzer to see if it works. It's a high-risk, high-reward strategy that paid off big time. And finally, the third cheat, skipping the boring parts. Some parts of a program, like decompressing a file, are incredibly complex to analyze, but they rarely contain the kinds of bugs we're looking for. QSYM actually learns to recognize these repetitive, compute-heavy sections and just ignores them. It prunes them from its analysis, preventing it from getting bogged down in areas that are unlikely to give any results. So you have this system built on all these clever cheats. It's pragmatic, not perfect. How did it actually perform in the real world? Well, the results were nothing short of stunning. Okay, get this. Running on a single computer, QSYM unearthed 13 previously unknown, high-impact security bugs. And these weren't in some obscure software. No, these were in major, heavily tested programs that millions of people use every single day. This chart really says it all. In a standard academic benchmark, the previous state-of-the-art tool, VUzzer, found 95 bugs. Now look at QSYM. With its clever cheating, it found 1,368. That's a staggering 14 times more effective. Just incredible. This slide compares QSYM to Driller, the previous leading hybrid fuzzer. The blue squares show tests where QSYM found more new areas of code to explore. The red is where Driller did better. I mean, just look at that. It's a sea of blue. In over 82% of the tests, QSYM's pragmatic approach simply explored more of the software more efficiently. And this isn't just about benchmarks. Look at this list. We're talking about ffmpeg, the engine behind countless video players, TCP-jump, a fundamental tool for network analysis, libarchive, which handles zip files on millions of systems. These are absolute titans of the software world, and QSYM found serious flaws in every single one. But this is the real kicker. This quote from the paper says it all. These programs had already been through the ringer with OSS Fuzz. That's Google's massive bug hunting project that runs on hundreds of servers. And OSS Fuzz missed these bugs. QSYM found them on a single computer. Just let that sink in for a minute. You know, the story of QSYM is this powerful lesson in engineering and really in problem solving. It proves that sometimes a clever, pragmatic cheat can totally outperform a theoretically perfect but impractically slow solution. Which leaves us with a final thought-provoking question. Where else in our world, in technology and beyond, could a good enough but fast approach beat a perfect but slow one?